Hi everyone. So today I'll be explaining about Advanced Driver Assistance System, which is ADAS. I'm a student from UMPSA. My name is Gan Tianbei. My student ID is TG22050. The subject is BTE 4733 Sensor Technology, and my lecturer name is Dr. Muhammad Razali bin Daud. So the agenda for today is introduction, transmission range sensor and ultrasonic sensor, which is ultrasonic sensors, explanation, system performance analysis, and also discussion. So in this slide, which is this presentation, I'll be explaining about the sensor technology for ADAS. So ADAS stands for Advanced Driver Assistance Systems. It is a group of electronic systems in a vehicle designed to assist the driver, increase safety, and reduce accidents by sensing the environment and responding intelligently. The main function of Advanced Driver Assistance System (ADAS) is to enhance vehicle safety and driving comfort by monitoring the driving environment and assisting the driver in making safer decisions. Two of the main sensors that I'll be explaining and also that will be used in ADAS are ultrasonic sensor and also transmission range sensor. So transmission range sensor, which is the gear position switch, is a type of electromechanical switch or Hall effect sensor. So usually it will be mounted on the gearbox or the gear shifter assembly. It is to detect the gear, which is the current gear position. For example, are the gear in the is the gear in the reverse or is the gear in the 1, 2 or D, which is the moving. So the main function is to monitor the physical position of the gear level. Its only job is to answer the question, is the car in reverse? So why is this transmission range sensor needed in ADAS? The sensor acts as the trigger. It will only be activated when the car is in reverse. So without the transmission range sensor, the parking sensor will keep beeping when driver is driving forward in traffic, which is not necessary. Then we wouldn't need the sensor to working when the driver is driving forward in the traffic. The main thing is only used when the driver is reversing for parking. So the next sensor used is ultrasonic sensors, which is the partronic sensors. Ultrasonic sensor is a type of piezoelectric transducer, which is transceiver. Usually it will be located at the rear bumper, 4 to 6 small circles embedded in the rear bumper. So usually we can see our car, right now the technology car, we have the sensor embedded in the rear bumper and it is a very obvious shape. So this act like a bad sonar. They contain piezoelectric crystal that vibrates to create a high frequency sound pulse, ultrasonic sound pulse, and then listen to the echo. So why is this ultrasonic sensor needed in this ADAS system? This sensor acts as the detector. It provides precise distance data for objects in the driver visual blind spot. It also enables a proactive warning system, which will be gradually beeping rather than a reactive one, which is only beeping upon contact. So the gradual beeping function is actually to warn the user, which is the driver, that it is approaching a certain object or certain place that will be having the contact with its car, with the driver car. So if to alert the driver and also give a warning, and also to assist the driver in having a better parking. So these two sensors work together by sensor fusion, which is when the driver selects reverse gear, the gear switch as the system trigger, signaling the controller to activate the bumper mounted ultrasonic sensor by fusing the gear set with the acoustic data. The system accurately calculates distance between 30 cm to 2.5 meter range with a precision of plus minus 3 cm. This distance is then converted into a digital signal that triggers a variable frequency audio alert, providing driver with proactive feedback increase in intensity as the vehicle, the driver approach a hazard. So through this picture, we can see the Volvo car is having in a situation to park the car. The drivers want to park the car. So it having the is when the driver is in reverse, the car will start having sensor to work. So the ultrasonic sensor will start to send echo signals to detect the nearest object to assist the driver in parking the car. So next. So this is the system performance analysis. The system accuracy was verified by comparing measured sensor data against physical rural measurement, yielding a precision error of less than 3 cm. So the observation of the blind zone confirmed the sensor successfully detected a 50 cm tall obstacle that was completely invisible to the driver's mirror. This is one of the example. So let's say that the blind zone include a 15 cm tall obstacle. The system will help the driver to identify the 15 cm tall obstacle, and it will assist the driver to avoid the obstacle, to avoid any contact between the obstacle and the car. So, analysis of the feedback loop show that the audio beeping frequency is adjusted in real time as the vehicle approached the hazard, ensuring the driver had adequate reaction time. You can see through many real-life experience when a driver is driving his car and having parking situation, the sensor will start beeping to alert the driver about the environment, which is obstacles. So it is very useful to assist driver to prevent any accidents to happen when parking, like having contact with other people cars, usually in the parking zone or parking lot. Okay, so testing the stop. The next one is testing the stop threshold verified that the continuous alarm tone consistently trigger at around 30 cm, providing a reliable safety buffer to prevent impact. Reliability checks reveal that while the system performed perfectly in total darkness, he still on the sensor phase led to a significant loss of signal integrity. So in this the system performance analysis is to show that how the system, which is the sensor fusion, works together in a car. So which is the ADAS we mentioned earlier. This is the whole system for that, and this is the system performance analysis. So next we will be looking at the discussion part. So the discussion part will include the two sensor, which is the transmission range sensor and also the ultrasonic sensor. The function, we will first talk about the transmission range sensor. So the functionality or application will be an electromechanical switch that acts as the system primary trigger by detecting reverse gear engagement. The accuracy or sensitivity for the transmission range sensor is high binary accuracy, which is sensitive to the precise mechanical movement of the gear linkage. Measurement range is discrete stats only, which is PRNDS. Signal output is digital, which is logic high or logic low, or CAN bus data packet. The reliability factors: mechanical wears of the gearshift cable or loose connector. The next one is the ultrasonic sensor. So the functionality or application is it uses a piezoelectric vibration to emit sounds, pulse, and listen for echoes, sonar to detect nearby objects. The accuracy is usually high precision from 1 to 3 cm. Highly sensitive to hard reflective surface like walls. The measurement range is effective direct detection from 30 cm to 2.5 meters. Signal output is using the digital pulse width modulation (PWM), where the pulse width repulsion distance respond to the sorry, where pulse with repulse to the listen response to the system. Reliability factors include the physical blockage by mud, ice, or snow on the sensor face. So when having the physical blockage by mud, ice, or snow on the sensor, it will still work, as it can deflect, it can uh, give out wave deflection caused by stiff angle. So this is basically the presentation from me for the ADAS, which is